reflection is a transformation that uses a line like a mirror to reflect an image. So, like translations slide, reflections flip, and they flip over a line. And in our case, we're going to focus on reflections that flip over an axis, the x-axis or the y-axis. So if you remember, reflections are also isometries. Remember that an isometry is a transformation that preserves length and angle measure. It does not change size or shape. It maintains its size. So transformations are isometries and reflections are isometries. So let's start by looking at what this looks like on a graph, and then you'll see that there's a pattern and you can form a rule from this. So the first thing that we want to do is we want to take this original triangle ABC and we want to reflect it across the y-axis. So this green highlighted line right here, that's the y-axis. So it's going to maintain its distance away from that axis. So if you count, A is 1, 2 spaces away from the y-axis. So I'm going to keep going. It's going to flip to the other side, and it's going to go 1, 2. So my new A, my A prime, is going to be right there. So then my B, if I count 1, 2, 3, 4, 5, 6. So if I continue, count 6 more, 1, 2, 3, 4, 5, 6. My new B, my B prime, goes right there. And then my C is 1, 2, 3, 4 away. So it will maintain 1, 2, 3, 4 away. So C prime. Just like when you're looking in the mirror, your reflection is the same distance inside the mirror as you are away from the mirror. So that is the reflected triangle about that axis. So let's look at our points. So A is at 2, 1. B is at 2, 4, 6, 2. And C is at 4, 5. So if we go and we look at our coordinates for our transformed for our image, then A prime is at -2, 1, B prime is at -6, 2, and C prime is at -4, 5. Now look at those. Look at what you noticed. Look at what changed and what didn't. Look at your X values on every single one of these. They became the opposite of what they were. But if you look at all your Y values. All of your Y values stayed the same. So the rule then would be, if you're reflecting across the Y axis, we'll go down here and write the rule. If we're reflecting across the Y axis, my original XY becomes -X, Y. So when you're flipping over the vertical axis, your horizontal coordinate, which is X, is going to change. So now let's go back to our original. Let's rewrite our original coordinates: 2, 1, 6, 2, and 4, 5. So we're back to our original. Now I want to reflect across the x-axis. So here is my x-axis. I want to take my original shape and I want to flip it across the x-axis. So it's going to change vertically. So A is 1 above, so it will be 1 below. B is 2 above, it will be 2 below. And C is 5 above, so it will be 5 below. So here's my new triangle. And if I write down the coordinates for that new triangle, I'm at 2, -1, 6, -2, and 4, -5. Now again, let's go back and let's look. Look at what changed and what didn't change. So what you should notice is that my X values all stayed the same, but my Y values became the opposite of what they were before. So the rule then for reflection across the X-axis would be that XY will become, my original X, my original Y will become, my X will stay the same, and my Y will change. So notice that when I am flipping across the x-axis, it's my y value that changes. When I'm flipping across my y-axis, it's my x value that changes. And you can do that by just thinking about flipping your hand over vertically or horizontally. So if you're flipping your hand across the y-axis, you notice you move your hand horizontally. If you flip your hand across because you're flipping like this. If you're flipping across the x-axis, you would flip your hand vertically so that it changes like that. Okay, so let's use DEF and let's practice this. Pause it if you want to try it on your own, but we want to reflect across the x-axis. So my x-axis is right here. Now, notice that this time my shape is on the x-axis. So basically everything is just going to flip, like you're going to turn, like that's a triangle on a straw, and you're just going to turn that triangle 180 degrees. So D is 2 below, so it's going to go 2 above. E is 4 above, it's going to go 4 below. And F is 4 below, and so it's going to go 4 above. So it's going to flip like this. Now you can do this following those same rules. I'll show you, but I want you to see that you can also get it by just looking at the picture and flipping it over. So originally D was at 4, -2. E was at 7, 4. And F was at 8, -4. That was the original coordinates. So I'm flipping across the x-axis. We can still follow that same rule, right? So the rule is that x, y becomes, if I'm flipping across the x-axis, I'm changing vertically. I'm flipping it this way. So it's your x values are gonna stay the same and your y values are going to change. So let's look then. If you look at your D went from being 4, -2 to 4, 2. So my y value changed to be the opposite of what it was. So it was 4, -2, now it's 4, +2. Okay, my E, the x value stays the same. The y value was 4, now it's -4. And the F, the original x value was 8. It stays the same. The y value is -4. It changes and becomes +4. So those still follow the rules. It doesn't matter where it is. If you're flipping across the x or y axis, you can always follow those rules. So now, if we go back to this, let's just use the rules and not use the picture to reflect those same points, D, E, and F, across the y-axis. So if I want to flip them across the y-axis, remember that your rule is that x, y becomes, if I'm flipping across the y-axis, I'm changing horizontally. So my x value will change and my y value will stay the same. So my original value was at 4, -2. It's up here. Okay, where I wrote it down already, so I don't want to write it again. So my original value is at 4, -2. If my x value changes, then it becomes -4, -2. My x value changes, my y value stays the same. My E will change, my x value will change, -7. My y value will stay the same. And for F, my x value will change, my y value will stay the same. Okay, so it's beneficial to not just memorize the rules, don't memorize the rules, but understand why they work the way they do. So let's look at this last example. If I have F at -2, 4, and you can always draw it on a graph to see it, and then G is at 2, 4. What are the new points if you reflect F, G across the x-axis? So at first, if I want to reflect them across the x-axis, if this is my original axis, well, F was at -2, 4, so flip it across the x-axis so your y value changes. It's at -2, -4, and G would be at 2, -4. So it's going to go and it's going to look like this. It's going to be -2, -4. So that's what it would look like if you reflected it across the x-axis. If you reflect it across the y-axis, the original picture, look what happens. F becomes, so you're going to flip it across the horizontal, so your x values are going to change. So my F becomes +2, 4, because originally it was -2, 4. So F becomes your +2, 4, and G becomes your negative 2, 4. So they trade places. So when you do this the second time, then this becomes F prime and this becomes G prime. So it just rotates itself and it looks exactly like it did before, except if F and G were different points, then they would be switched. Okay, so translations slide and reflections flip. And you can always go back to a graph and understand how it works, but it is a lot easier if you understand the rules.